Hi everyone. For these next three videos, I'm just going to go through three examples from the textbook, section 3.2. That might sound like, oh gee, then I'll just read the textbook, which is fine too. But I think sometimes it helps going through the examples out loud. So for this first example, I'm using different Venn diagrams that I found online that I really like to sort of show how you use Venn diagrams both in a classroom and for understanding. This first one is from learnnc.org, and it's about creatures that have wings or creatures that are extinct, or in the middle, you see here, they're both. So the first thing I'd like you to do is think of an element of the set W have wings and how you would write it using the correct symbol. If you want, you can pause the video and think about it now. So if you want to write is an element of, that's the funny E symbol. Hi everyone. In the next three videos, I'm going over three examples from section 3.2. If you prefer reading about it, that's fine too. But sometimes I think it just really helps to go over the examples out loud. This first one is something from learnnc.org, and it's something you would use in grade school to show the students about creatures that have wings versus creatures that are extinct, and how some creatures that have wings, or that could fly, if you want to say that, are now extinct. Dodos, by the way, had wings, but they could never fly. So let's go to the first question. Name an element of W and use the correct symbol to write it. So W is have wings, and it's this whole set here. So you have to remind yourself of from the previous section of how you're going to write that. So to write is an element of, we would use this funny E, and you can see flamingos is an element of W. By the way, dodos is also an element of W. W is this whole set right here outlined in red. Now let's talk about, one more thing. Dodos is also an E, right? So you could also write dodos is an element of the set E. Now let's talk about the number of subsets in a set. So the number of subsets you can find using this formula, y equals 2 to the n. So we would have to find the number of subsets that W has, we'd have to count how many elements are in it. I count 1, 2, 3, 4, 5, 6 elements in W. So we would have to do 2 to the 6th power. If you do 2 to the 6th power, you get 64. Notice dodos, pterodactyls, and passenger pigeons are all counted as part of W, even though they are also part of E. So think about for a second how many elements E has and how many subsets E would have. See if you can pause the video and figure it out. Use your calculator and actually get the number. So E has 7 elements, so it's going to have 128 subsets. So you count here 1, 2, 3, 4, 5, 6, 7 elements. And then on your calculator, if you're having any trouble with that, you want to do 2, and then the X to the Y key, or you might have a little caret that looks like this up here. And then you're going to use the 7th power, and then equals. So you get 128. And finally, I ask you to think about the intersection and the union of these two sets, and we're going to talk a little bit about set notation. So it's part C and D. So what would be the intersection of these two sets, and what's the symbol? What would be the union of these two sets, and what's the symbol? See if you can remember both those things from 3.1. So the intersection of the two sets is written like this. It looks like a little N for intersection, right? Intersection has an N, and it's the overlap between the two sets, dodos, pterodactyls, and passenger pigeons. It's what's right in the middle here between the two. The union, on the other hand, is written like a U for union, and it's all of the animals in both of those sets. So the union is everything in here, including the overlap. Finally, let's talk about why flamingos are in the left part of the circle, but not in the middle. See these flamingos? And how can we write that using sets? So we want to somehow say flamingos have wings, but they're not extinct. Right there, the way I just worded it, you can find the translation. So flamingos have wings, but, or we could say and, they are not extinct. So this is how we would write that. Wings and are not extinct. There's wings. The intersection symbol is and then not extinct is E with a little complement symbol, meaning not extinct. So we're just directly translating the words. So here's one last question for you. Two last questions, sorry. Where are golden toads and how would you describe them? These are animals that are extinct and do not have wings. So going back up here, golden toads are extinct, but they don't have wings. How would you use the same idea we just used here to write that? See if you can pause the video and try it out. And the other thing I'd like you to try out as you pause the video is think about this one out here, how you would describe this one using words and then using symbols. So pause the video for just a sec. We're almost done here. Give this a try before you go ahead and listen to the answer. So golden toads are extinct and do not have wings. So we would say they're an element of E. Intersect, not W. And that intersection gives you the word and the not W is the complement symbol. The animal X that's outside of everything out here, we could write in a couple of different ways. So I hope you figured out one of these two. Either one is fine. We could say it does not have wings and is not extinct. Or we could say it's not true that it has wings or it's extinct. So that's a little funnier wording, but you might have thought of the second version of it because it's outside, the X is outside of these two circles. These two circles are the union, right? And X is out here outside the union of the two circles. Now, the fact that these two are the same is something we're going to explore in our last video for this section about De Morgan's laws. So, the other thing I'd like you to think about is in elementary school, you're not going to use all the set notation that we use, but you are going to use Venn diagrams, or I hope you will, to organize and categorize. This one example that I got is from, I think it's a homeschooling group, and it was to try to organize how students thought about those two kinds of things. So I'd like you to think, how would you use it? Maybe more realistically than this, because I'm not sure students would really be interested in this. So think about what students would be interested in and how you might use a Venn diagram to show that. See you in the next video.